Welcome to this video on the VCAA Mathematical Methods Exam Paper 2, Technology Active. In this session, we work through step-by-step solutions to the multiple choice questions, share helpful exam strategies, study tips, and powerful calculator techniques. This video is produced with the permission of the Victorian Curriculum Assessment Authority and is subject to copyright. The VCAA does not endorse or make any warranties regarding this resource. So, let's kick off with exam tip number 1. You have 15 minutes reading time. Use it wisely. Most students will spend part of their reading time looking for the correct answer in each multiple choice question. My tip: you also need to look for the distractors. Examiners have years of experience and data, so they know the common mistakes that you're likely to make. Use your reading time to scan for these traps. If you can spot the mistakes examiners expect you to make, you'll be less likely to fall for them. There are more tips provided throughout this video, including some very powerful reflections at the end that will help make sense of the approach that we're going to use throughout this tutorial. So, stay tuned and let's get started. Question 1. 70% of students got this correct. 20% chose the same incorrect answer. Can you spot which one they selected? The argument for the logarithmic function must be greater than 0. The argument provided in this question is x plus 1. Therefore, x plus 1 must be greater than 0, so x must be greater than negative 1. Now let's check the answer using a graph. I'll graph the function natural log of x plus 1 minus 3. It's reasonably clear that one of the asymptotes occurs at x equals negative 1. Look at the other alternatives provided in the question. Option B says an asymptote at x equals 1. So that option is out. And option C says y equals negative 3. So that too is out. Which means option D is also out. Option A is the only correct response. You've already jumped past 26% of students that took the exam in 2024. To be fair, last year's students weren't watching this video. The superiority or confidence you may be experiencing right now is called confirmation bias, a sort of Dunning-Kruger effect in action. So here's my second tip. If you haven't already completed these exam questions, hit the pause button at the start of each question and try the question. Doing is proven to be much more effective than simply watching and listening. If you get the question wrong, don't be disheartened. Your brain learns from mistakes. Study time is about feedback, finding out what you know, how well you know it, and what you still need to do to fix it. We have questions that you can download for extra practice when you're done here. Question 2. Don't forget, pause the video and try the question. This question was done quite well, with 80% of students getting it correct. So let's check it out. We are provided with information about the derivative of g of x. We are asked to find the value for g of 2. That means we need to determine the antiderivative of x cubed minus x. You can do that by hand, but there is some substitution coming up. So to be on the safe side, I'll insert a new problem, add a calculator application, and determine the antiderivative. Use your shortcut keys, Shift and plus, x cubed minus x, and we get x to the power of 4 over 4 minus x squared on 2. Right now, you may be tempted to substitute x equals 2. But if you are following along with tip number 1 in mind, you won't fall for that old trick. The integral needs a plus c. Now I can use the other information provided in the question, that g of 0 equals 5, so we get c equals 5. Now calculate g of 2 given c equals 5. And we get 7, which is option D. Question 3. It's a new question, so I'll insert a new problem. You'll see why later in this video. It's time to pause and try the question. This question provides information about a probability distribution that is populated with k rather than specific numeric probabilities. We are asked to find the probability that x is less than 4 given x is greater than 1. So what does that mean? Given that x is greater than 1 tells us that our sample space has been reduced to just this part of the distribution or table. In other words, x equals 0 and x equals 1 did not happen. With this in mind, we are asked to find the probability that x is less than 4, which corresponds to these remaining options. These remaining options correspond to the intersection of x less than 4 and x greater than 1. We have 8k favourable outcomes over 10k possible outcomes, which simplifies to 4 over 5. We didn't even need to calculate k, nor did I press any buttons. But let's see what this might have looked like if I tried it on the calculator. For this question, it took longer to use the calculator. Keep an eye on the time and make appropriate decisions about when to use the technology. Before we move on, think about the distractors. Look at the most common errors from 2024. What might have led students to make these errors? Question 4. We need to compute a definite integral, but we are not provided with the function or the values on the terminals. I'm going to demonstrate 2 ways to solve this problem. The first option is to work directly with the integrals. If the terminals on the first integral were swapped, then we can reverse the sign. Now we have an integral from b to a and also from a to c. Now we can compute the integral from b to c. The question asks for the integral from b to c for 2 times f of x, so we simply multiply our answer by 2 since the 2 in this case is operating on the output rather than the input. So the answer is 16, which aligns to option B. Another way to look at this problem is to use a visual approach, that is, draw a diagram. Take a moment to study these visuals. The definite integral from a to b is -5, and the definite integral from a to c is 3. So the blue region must be equal to 8. It was somewhat surprising to see that this wasn't one of the distractors in the question. And all that is left is to multiply the result by 2 to get the correct answer. 70% of students were able to get this question correct. The relatively even distribution of other responses across the alternative answers suggests that perhaps up to 40% of students were actually guessing and 10% guessed correct. This is the type of question worth returning to at the end of the exam if you have time, and use your calculator to experiment. Question 5. We are given two functions, f of x equals x squared minus 4x over a restricted domain, and g of x equal to e to the power of negative x. We are asked to find the range of the composite function g of f of x. Now take a moment to think about tip 1. What things are likely to go wrong here? Hit the pause button and give the question a try. I'll start by defining f of x over the restricted domain. And then g of x. Now I can graph g of f of x, and remember, we are looking for the range of this function. You can change the window setting through the menu, or hold down the Shift key and just drag the y-axis. Calculate the maximum value. It's not super helpful given that the answers are provided as exact values, but it appears to occur when x equals 2. Substituting that in gives us e to the 4, and this value is included. I could check the minimum value, but all four options have the same minimum value, so our answer is D. Question 6. In this question, we are asked to find the inverse. Take a moment to think about the necessary conditions for an inverse to exist. And hit the pause button and give the question a try. Insert a new problem. Define f of x equal to 2x plus 1 divided by 3 minus x. We can find the inverse by swapping x and y and solving for y. Our answer looks a lot like option A. Recall tip number 1, examiners know the types of mistakes that you're likely to make. The device in your hand is called a calculator, not a thinkulator. So have a look at the domain restriction for option A. It doesn't look quite right. The domain restriction should indicate that x cannot equal negative 2, which aligns to options B, C and D. So let's try and express our answer as a proper fraction. Equations A and B are algebraically equivalent, but option B has the correct domain restriction. Now let's have a look at the student responses from 2024. Only 50% of students got this question correct, but notice that 31% of students fell for option A. Exam tip number 1 to the rescue again. Question 7. A fair dice is rolled repeatedly. We are looking for the probability of rolling at least 1 6 being greater than 95%. Let's take a moment to understand the question. Suppose I choose 15 rolls. For the purposes of this video, I'm going to simulate this on the calculator. This is not something you'd be doing in the exam, but we're doing revision and we want to understand the question. In my first sample, I have at least 1 6, so I'll roll again. And again, I got at least 1 6 present, so I'll keep on going. Suppose I did this 20 times. Would it be reasonable to say that 19 of these samples would contain at least 1 6? If so, that would correspond to option A. If I roll the dice 16 times, we would have a slightly higher probability of obtaining at least 1 6. So after 20 of these trials, it might seem reasonable to expect that only one sample will contain no 6s. Now, think about what you were checking for in these samples. Were you counting the number of 6s, or were you simply looking for a sample that contained 0 6s? Furthermore, we were looking for one instance in 20, 5%, of a sample containing 0 6s. We have flipped our thinking about this problem. Now pause the video and try the question. We need to calculate the probability of 0 6s being less than 5%. To do this, I can use the inverse binomial command for n. The cumulative probability is 0.05. The probability of success is 1 on 6, and we want 0 successes. Generate the result as a matrix. The matrix tells us that if I roll the die 16 times, there is a 0.054 chance that no 6s will come up, or a 94.59% chance that at least 1 6 will turn up. If I roll the dice 17 times, there is a 0.045 chance that no 6s will come up, or a 95.5% chance of at least 1 6. Now remember, the question asked us to find the probability of at least 1 6 being greater than 95%. So our answer is 17. Notice that 15% of students made the mistake of choosing 16. What mistake were they making? Question 8. This question relates to addition of ordinates, or in this case, subtraction of ordinates. The first row of the table represents a selection of x values. The second row is a corresponding y value for the function f of x. The third row is the corresponding y value for the function g of x. We can therefore work across the table and work through each point. When x equals 1, f of 1 is 0, and g of 1 is 3. So f of 1 minus g of 1 equals -3, which is not an x-axis intercept. When x equals 2, f of 2 equals 4, and g of 2 equals 4. So f of 2 minus g of 2 is equal to 0. So we have the point 2, 0, which is an x-axis intercept. When x equals 3, f of 3 equals 5, g of 3 equals -5, so f of 3 minus g of 3 equals 10, which is not an x-axis intercept. So the answer is A. Question 9. This question involves some conditional probability information. A tree diagram will service this question well. According to the question, a student either travels by limousine or not. The probability that a person travels by limousine is 0.45, so not limousine is 0.55. The next branch of the tree is for a student getting their professional photo taken, or not. Of the students that travelled by limousine, the probability of a professional photo is 0.3. So the students that travelled by limousine and did not have a professional photo is therefore 0.7. Moving on to the students that did not travel by limousine, we're told that the probability of getting a professional photo was 0.6 and therefore not getting a professional photo 0.4. With the tree diagram complete, we need to find the probability that a student travelled by limousine given they had a professional photo taken. So that's 0.135 over 0.135 plus 0.33, which equals 9/31. That corresponds to option C. Question 10. Before you pause the video for this question, I want to provide a hint. Draw a diagram. Now, go ahead and pause the video and give this question a go. Only 38% of students got this question correct. However, the relatively even distribution of incorrect responses tells us that it is likely that only 20% of students knew how to answer the question. It's not necessary to use your calculator for this question. However, I have created a graph so we can head straight to the understanding part. The graph I've created is a relatively simple one, a parabola, which is dangerous, but we will proceed with caution. The graph is defined and continuous over the interval from 0 to 5, so too the derivative. We are told that the derivative or gradient of the function at x equals 2 is negative. So far so good. And the derivative of the gradient when x is 4 is positive. Again, so far so good. The original function and the derivative are continuous. The derivative is negative at x equals 2 and positive at x equals 4, so somewhere between 2 and 4 there must be at least one point where there is a gradient of 0. Furthermore, since the function was decreasing and is now increasing, at least one of those 0 gradients will correspond to a turning point. And here's where we need to be careful. The question asks which one of the following must be true. In other words, if I chose another function that satisfies the above criteria, the selected statement must remain true. So let's have a look at option A. While the function that I have chosen is decreasing over this interval, I could easily put a different polynomial, say of higher degree, and now the previous criteria are all satisfied, but option A is no longer true. So let's have a look at option B. F does not have an inverse. If I graph the inverse, I get a relation. And regardless of the graph I put here, because there's a turning point between 2 and 4, my inverse will be a relation. So, I've found the correct response. But we're not done here. Spend some more time thinking about why the other responses cannot be true. And now, it's time for another tip. These questions can be tricky. They can take up a lot of time. They may even cause you to second guess yourself. Remember, you got to this space in your education because you're good at maths and you persevered when others gave up. So, at this early stage in the exam, it's not the time to be spending too much time persevering. There are still lots of questions to go. If you're not ready to commit to an answer, make a note and come back. Question 11. Before you press pause, a point of clarity. Unlike question time in class where the same student may be chosen twice, assume in this question that once a student is chosen, they are effectively removed. Now, press pause and try the question. While this question belongs to the hypergeometric distribution, it is relatively easy to set up a tree diagram. A student is either in the first row or the second row. Initially, there is a 7 out of 12 probability of choosing a student in the first row and a 5 in 12 probability of choosing a student in the second row. These probabilities change each time a student is selected. The question asks us to find the probability of selecting exactly 2 students from the first row. So you can save yourself some time by only creating the relative branches. If our first selection is from the first row, there will be one less student in the first row and one less student in the student population. So there is a 6 in 11 chance of choosing another student from the first row and a 5 in 11 chance of choosing a student in the second row. The question asks for exactly 2 students in the first row. So if I continue along this branch, I now must choose a student from the second row. That means the favourable outcomes in this part of the tree diagram is equal to 7 over 12 times 6 over 11 times 5 over 10. Continue watching as the relative parts of the tree diagram are populated. Each of the 3 relevant branches results in the same probability. (7 over 44). As we have 3 branches, each one of equal likelihood, we get a probability of 21 over 44, which corresponds to option B. If you're not comfortable missing parts of the tree diagram, pause the video and complete it for yourself. Remember, you are currently doing revision. Now is the time to find clarity and confidence about your answers. Thinking back to tip number 1, look at the proportion of students that selected option D. What mistake do you think they were making? Question 12. This is the type of question designed to negate the use of your calculator. Press the pause button and give the question a try. The graph is provided without a function definition, and we need to determine the effect of the transformation f of 2x plus 1. Now this question was not done well. So remember tip 1, examiners know the most common mistakes that students are likely to make. So we need to proceed with caution. Most of the errors and misconceptions around transformations occur when confusing inputs and outputs. f of x plus 2, for example, is operating on an input, whereas f of x plus 2 operates on an output. Before we lean on the calculator, there are some simple things you can do to eliminate some of the multiple choice responses. Let's start with the y-axis intercept, where x equals 0. If you substitute 0 in for x into the translated function, f of 2x plus 1 becomes f of 1. So we need to determine where this value was on the original graph. It looks as though it was approximately 2.5. Therefore, the y-intercept of the transformed function should be approximately 2.5. This eliminates option B, which 28% of students chose. Let's try another point, say x equals negative 1. Our transform function, f of 2x plus 1, needs us to evaluate f of negative 1, which we can look back at the original function and see that f of negative 1 equals 1. So f of 2x plus 1 must now pass through the point negative 1, 1, which leaves us with graph A as the only option. Now let's see, could we do the entire problem on the calculator? Or even just check our current answer? It may be challenging to guess the function. For convenience, I'm actually going to imagine moving the entire function down 1 unit. That gives me a point of inflection and a turning point on the x-axis. I can achieve this by having a cube factor for the point of inflection and a squared factor for the turning point. The shape's quite similar. In fact, I can fix the y-intercept by dividing my function by 4. Now I'll just shift the graph back up again. The graph actually looks remarkably similar. Now I can graph f of 2x plus 1, which looks remarkably like option A. If you'd like to better understand dilations and transformations, particularly dilations and dilation factors, and understand the difference between inputs and outputs, there are some links in the description below and also on the TI Australia website in the student section. Question 13. This question was also poorly done, and it too relates to transformations. So, if you're like half the students that did this exam, you may have struggled with the previous question. So now may be the time where you watch and then try, as I tackle this question a different way, with a view to helping you understand transformations. I'll start by graphing f of x. The question asks about a local minimum on g of x, where g of x is a transformation of f of x. I'll put a point on the minimum value of f of x. This occurs at 2, 2. For the purposes of this demonstration, I'll store these coordinates as xp, yp. The question says the transformation includes a dilation of 3 units away from the y-axis. So I'll plot a point such that the x value is multiplied by 3, corresponding to a stretch of 3 units away from the y-axis. And for the y value, a translation of 1 unit in the negative y direction. The question only asks for the coordinates of this minimum on g of x, so we don't need the equation. But for completeness, and in preparation for similar questions, let's see how to generate the answer. The transformed function is a set of points x primed, y primed, where x primed equals 3x, that is the stretch by a factor of 3 away from the y-axis, and y primed equals y minus 1, a translation of 1 unit in the negative y direction. We need a relationship between x primed and y primed. We are provided with a relationship between y and x. So we rearrange the two equations. X equals x primed on 3 and y equals y prime plus 1. We can now substitute our values for x and y into the relationship we know about x and y. So we get y plus 1 equals f of x over 3. And look, it aligns perfectly to our translated point. There are more questions just like this in the student section of the Texas Instruments website. Question 14. Only 53% of students got this question correct. So once again, proceed with caution. Press the pause button and give the question a try. We are provided with a PDF. The definition includes a parameter k, and we need to find a specific probability. Start by defining the distribution. We know the sum of the probabilities for the probability distribution is equal to 1. And as this is a continuous PDF, we use the integral. You can do this from negative infinity to positive infinity, or simply from negative 3 to 1. Now solve for k. Notice that the value for k matches one of the multiple choice responses. This is a common mistake. You see an answer pop up on your calculator, that matches something in the exam, and you exit the question too early. This is why examiners say, read the question. So let's check the question. We need to find the probability that x is less than or equal to 0.5. Establishing the value for k is just something we need to do in the process. Now we can calculate the integral from -3 to 0.5, and we get a probability of 0.9375, which we can convert to a fraction, which aligns to option B. Question 15. This question should have been relatively straightforward, yet only 53% of students got it correct. Furthermore, the distribution of incorrect responses indicates that in fact the majority of students were probably guessing. So we will proceed with caution. We're given a function and asked about the points of inflection. The first part about this question that should grab your attention is it refers to points of inflection, since we're more commonly asked about turning points. A point of inflection does not necessarily have a gradient of 0. However, the second derivative will be 0, which is a great place to start. In this question, it's going to be more time efficient to define the function, as we need to determine points, not just the x values, and it's always worth checking the graph. So I'll start by defining f of x equal to 2 minus tan of pi times x minus 1 on 4. Now solve. Second derivative of f of x equal to 0, solving for x, and we get a general solution. But our general solution has a common denominator, so it doesn't look exactly like the solutions provided in the question. Furthermore, it provides us with a -3/4, where our solutions have either a plus or minus 1/4. I'll express the general solution in terms of k and substitute some values. We get 1/4, 5/4, 9/4, which aligns to options A and C. Now, if we substitute these values into the function, we get a y value of +2, so the answer must be A. Given the responses from the students that did this exam, it's definitely worth checking the graph. From the graph, we can see the coordinates for the points of inflection occur along the line y equals 2. So options C and D are definitely wrong. We can use the Analyze tool to locate the points of inflection. There's one at 1/4, 2, another at 1 1/4, 2, and so on. These align with the values produced in the calculator application, confirming that A is the correct answer. Question 16. With the power of hindsight, it is abundantly clear that the vast majority of students guessed their answer to this question. So before you pause the video, I'll give you a clue. Try exploring the question on your calculator without defining anything for f of x. Okay, let's give this question a shot. We're not provided with a definition for the function, but we are provided with specific values for the function and its derivative at a specific point. Then we're asked to find the gradient of the square root for the same function. I'll insert a calculator application, and whilst I can't define f of x, let's see what the calculator does with the derivative of the square root of some unknown function. The calculator tells me to divide the derivative of f of x by 2 times the square root of f of x. Now all I need to do is substitute the information provided into the question into the result produced by the calculator. The numerator is f' to 4, which we were told is 15, and I can divide this quantity by 2 times the square root of f of 4, so 15 on 2 times the square root of 25, which is 3 on 2, aligning to option D. Other examples of this type of question might involve things like the product rule. We have more of these types of questions for you to practice in the student section of the TI Australia website. There's a link in the description below, or you can request the resources via the comments. Question 17. This question relates to pseudocode and algorithmic thinking. But just like the previous question, the results indicate that almost all students were guessing. So I'll assume nothing and progress step by step. The first line of code tells us there's a function definition that follows. The second line tells us that the value sent to the function will be substituted and the output returned. This is the same as defining a function on your calculator. The third line of code tells us that the first or seed value of C is equal to f of 0. So we can just substitute that in and get 18. Now we can start moving through the logic statements. The fourth line of code checks to see if C is less than 0. And it's not. So we can skip this part of the code. The next line of applicable code is a while loop. I believe this is where students may have come unstuck or confused. The value of C was generated by substituting it into f of x. And now we're substituting that result back into f of x. But if we can move past this confusion and just think about the current value of C and then follow the code. While C is greater than 0, well, the current value of C is 18, so the line is checking while 18 is greater than 0, which is true. So we proceed to the if statement. If f of 18 equals 0. Well, f of 18 equals 5040, so that statement is false. And therefore we can skip to the next section of applicable code. If f of negative 18 is 0. Well, f of negative 18 equals negative 6300, so this statement is also false. And we can skip to the next section of code. Here, we are required to reduce the value of C by 1. So now, C equals 17, and we go back to the start of the loop. The if statements will only be true when f of C equals 0, or f of negative C will equal 0. So, it will be helpful to find the roots of f of x. If we solve f of x equal to 0, we get negative 3, 2 and 3, which we kind of could have assumed by the answers, I guess. C starts at 18 and is reduced by 1 each time we progress through the loops. So the first solution we will encounter will be when x equals 3. This will make the first if statement true, and the algorithm will print 3. But the second if statement will also be true, since f of negative 3 is also equal to 0. So the second value to be printed will be negative 3, leaving 2 as the last value to be printed, and this sequence of outputs aligns to option D. Depending on when you're watching this video, you may want to try the free 10 minutes of code lessons on the Texas Instruments Australia website. If your exams are coming up soon, then focus on the textbook questions that help. And also try the free questions on the student section of the TI Australia website. Question 18. To calculate the area of the trapezium, we need an expression for the height. We can use Pythagoras' theorem and get h equals the square root of 100 minus x squared. So the area of the trapezium is gained by calculating the height and multiplying it by the average of the top and base of the trapezium. So now we have an expression for the area in terms of a single variable x. Solve the derivative equal to 0 and we get positive or negative 5 root 2. We know that x has got to be greater than 0. Check to make sure we have a maximum. And we can lock in option B. Question 19. This question relates to the normal distribution. However, we are not provided with the mean or the standard deviation. The first thing you may notice is that the two probabilities are the same. So the mean is halfway between 10 and 18. So we could conclude that the mean is equal to 14. We could make an estimate for the standard deviation, since we know that the probability that x is less than 10 is equal to 0.2, and x greater than 18 is also 0.2, which means 60% of the distribution lies between 10 and 18. 60% is less than one standard deviation either side of the mean, so our standard deviation must be a little bit bigger than 4. A diagram is always good. With the amount of information that we have gleaned from the question so far, you can actually draw a reasonably good graph using your calculator. A quick check to see how we're doing. The question asks us to find the probability that x is less than 12. Our estimate for the standard deviation is not quite accurate enough, so we'll need to do some calculations. The z-score for a probability of 0.2 is equal to negative 0.8416. Now we can substitute in our value for the mean and solve for s, and we get a standard deviation of 4.753, which aligns pretty well to our estimate. I'll adjust the graph accordingly, and we get a probability of x less than 12 being approximately 0.33, which you can also check using the normal CDF. Now we have u and s, we can work out the probability that x is less than 12 and get 0.337, which aligns to option C. Question 20. This question relates to the average value. So the first thing we need to do is understand what the average value represents, or at least remember the formula. So, populating the information from this question, we get k equals 1 over 2 times the integral from 0 to 2 of f of x dx. We are also told in the question that f of x is equal to f of x plus 2. So putting that back into the question, that means that f of 0 would equal f of 2, f of 1 equals f of 3, f of 2 equals f of 4, and f of 4 equals f of 6. Therefore, k would be equal to 1/2 times the integral from 2 to 4 of f of x, and also 1/2 the integral from 4 to 6 of f of x dx. And so relating back to the original question, 1/2 the integral from 2 to 6 f of x dx would equal 2k. We can move that half across to get 4k, which aligns to option C. Now, if you did not press the pause button on this question, and you just watched and nodded, that's what is known as confirmation bias. So here's a little glue to help make what we just did stick. The function f of x equals sine pi x plus 1 has the property that f of x equals f of x plus 2. And as we just covered in this question, that would mean the integral from 0 to 2 would be the same as the integral from 2 to 4 and 4 to 6. So hopefully this visual will help make this question stick just that little bit better. But do you want to know what really works? You need to try some questions and actually do the maths. So, that's a wrap for the multiple choice questions. As promised, here's another tip. You will have noticed throughout this video, I inserted a new problem each time I attempted a new question. That's enabled me to use f of x in multiple questions. But even more importantly, I can now return to check any previous question and pick up precisely where I left off. This is like having a superpower. If you learn nothing else from this video, use that superpower. It's incredible. Now see if you can remember all the study tips provided in this video. Take a moment to write them down. You'll be more likely to remember them. And if you can't remember them right now, rewind and locate them. Now that we have reached the end of the multiple choice questions, there will be a link to the short answer section in just a moment. Thanks for watching.